intercepts, remember you always have to factor. So all we're going to do is clean up the denominator. We know that's x plus 2, x minus 2. All right, we're done with that. The next are the wholes. Are you going to have holes on this? There's no holes, guys, because we do not have a factor that cancels out in the numerator or the denominator. And then let's go ahead and analyze our vertical asymptotes. Remember, the word vertical starts with the letter V, which reminds me of the down arrow. Vertical asymptotes always come from the denominator. So you're going to have two vertical asymptotes here, guys. 2 and negative 2. Those are the impossibilities. That's what will blow up the function machine. All right, so after that is my favorite part. It's the degree fight. We're going to analyze who has the most degrees from the printed problem. Where are most of the degrees? Denominator 1. Denominator always wants the horizontal asymptote to be y equals 0. And then next we find the zeros. And the zeros is the exact same thing as the x-intercept. So if you look at the top, guys, if you remember, I told you earlier, when you were solving polynomial equations, if you had a single x, it always goes to the origin. Same case here. We have a single x, it's multiplied by 3, but you don't have anything added or subtracted after it. So on your numerator, if you just have a single term for your x, nothing added or subtracted, it goes to the origin. I know that this graph goes to the origin because there's no addition or subtraction with the letter x. So that's the 0. And guys, since it goes to the origin, that's the same exact thing as the y-intercept. So if you graph it, the graph, of course, is going to look like this. Here's your two asymptotes at your negative 2 and your positive 2. There's where it went through the origin, but we knew it went through the origin because you just have 3x on the top. And then let's talk about what the domain is. So the domain for this, you're just going to block out your vertical asymptotes. Negative infinity to negative 2. Pick it back up to that other vertical asymptote. And then go ahead and pick it back up to positive infinity. Okay, the last one we're talking about today is this one right here. So we got to factor the top. That's going to be x plus 3 and then x minus 1. The bottom is already factored, so I'm just going to recopy it. So after we factor it, we figure out if there's a hole. Y'all, there's a hole here. What is the y coordinate for the hole? Negative 3. Because negative 3 would make that not work. All right? Now remember, it's somewhere on the coordinate grid. We don't know where it's at until you find the y coordinate. So the way that we're going to find the y coordinate is we're going to plug in that negative 3, and I think we already did this. So the y coordinate is negative 3 minus 1. So I know that hole exists out there at the negative 3, negative 4. After you find the hole, you look for the vertical asymptotes from your simplified version. Do you have a denominator? Then you don't have a vertical asymptote, so write none. After the vertical asymptote is the horizontal asymptote, and you would compare degrees at the top and bottom. There's no degrees in the bottom. All of the degrees are at the top, so the top wins. There's no asymptote. All right, so next is the x-intercept. Guys, remember your x-intercept comes from the top. Technically, I can write this as a fraction. We can make it look like that. So we do have a top. That's where the x-intercepts come from. What would make this equal 0? What would x have to be? 1. So this is going to be 1, 0. And then what about your x-intercept? Remember, 0 is what you plug in. Your y-intercept, you plug in 0 for x, so your y-intercept is going to be 0, negative 1. So if you look at the picture right on the other side, all of that stuff lines up and correlates. The last thing that I want to talk to you about is the domain. Remember, you do not have any vertical asymptotes, you just have a hole. So it's going to be negative infinity to that hole at -3, and then -3 to positive infinity. And that's going